our featured former fellow lunchtime talk, but it will only be online. There'll be nobody sitting here, or you can sit here and do it. Can't sit here. There'll be no food. Don't expect food. Okay. It is only a Zoom link, and you can find that on the center webpage. Next Friday, Faraz Azhar will be doing the lunchtime lecture. That's on the 20th on rethinking the anthropic principle. The former fellow lecture is on Tuesday is by Swazig Labian on how to secure public trust in value-laden science. And then the Friday one is on the anthropic principle. The following Tuesday, September 24th, noon, in person with food, is Porter Williams, who will be talking about the aim and structure of cluster decomposition. And then on Friday, the 27th, as you can see already, there's lots going on, is the first of our annual lecture series lectures, which happen at 3:30 p.m. downstairs and on the 10th floor. And that will be Thomas Rickman from Stanford University on Niels Bohr, transcendental physicist. All right, so a lot coming up. Mark your calendars, be here. And now it is with great pleasure that I will introduce Kevin Zollman, who is a good friend from across the gully from Carnegie Mellon University. He is the Herbert A. Simon Professor of Philosophy and Social Decision Sciences in the Department of Philosophy at CMU. And Kevin, his works on game theory, an agent-based modeling, and the philosophy of science. And so he has written a lot of things, including famously, what was this one called? The Game Theorist's Guide to Parenting. Should you need that? We do have some new babies in our department, but I don't. What's that?
I said an all system fill.
And more now that you're. But let me just announce, you can find out all that he does by looking at his webpage. He is open and available for conversation about any topic of your choice. Just email him, or he's not far away. And let me just mention that his upcoming book, is it in press yet?
Not in press yet.
Not press, but almost in press. Is under contract, is called Network Epistemology, How Our Social Connections Shape Knowledge, with Oxford University Press. And today he's going to be talking to us about authorship norms and the epistemic public goods. All right, take it away, Kevin.
Thank you very much, Sandy, and thank all of you for coming and being my guinea pigs today. This is joint work with my collaborator, Toby Hanfield at Monash University, and this is very much in the spirit of the Lunchtime Talk series. It's works in progress. Most of this work was done a month ago, so very fresh to all of us, and will be to you as well. But as a result, comments, of course, are always appreciated, but especially appreciated here. What we're talking about, and if you want to see the slides at your own leisure, they're available at this URL. You can look at them on your phone or computer if you want to go backwards or forwards at any point. So this project is part of a larger project spearheaded by Toby that looks specifically at questions about social norms in science. So in particular, the underlying question is a question about basically the emergence and role of social norms in scientific enterprise. Science is kind of surprising relative to a lot of other human endeavors in that it is very norm governed, and those norms are largely endogenous. So there's not a lot of governmental bodies that are interfering. There's not lots of threats of jail or punishment, but rather there's a lot of just entirely internal enforcement of social norms. And this is by far not a complete list, but just to get you sort of thinking about things that we're thinking about, there are lots and lots of these norms. So methodological norms very broadly. So one thing that I think is striking to anybody who's looked at more than one field of science is how, even if they're doing similar things, they might have very different norms about the proper way to conduct research. So in my neck of the woods, behavioral economists think it is absolutely unacceptable to lie to experimental subjects. Psychologists do it with abandon, and those are very strong norms. Your paper will be rejected by a behavioral econ journal, if you lie to your subjects, it will not be rejected by a psychology journal if you do that. Right? And that's just one example. There are tons of those. But also norms of statistical analysis in particular. The one, of course, that's gotten an enormous amount of press recently has been the norm that the threshold for considering a result significant is a p-value of less than 0.05 in most fields, 0.1 in others, and 0.01 in others. And that is, again, a norm, and a norm that differs from field to field, and one that we very much could alter, and that, in fact, some people are arguing that we should alter. But also there are a little less obviously explicit norms, but nonetheless still highly enforced ones. So norms of style and presentation are really severe. Anybody who's had the experience of trying to author an article in a discipline that is not the discipline where they did their PhD will have had that experience of getting criticism for not saying things in the precise way, or not having a methods section, or things that seem very superficial, but nonetheless are enforced quite rigidly by reviewers and editors. And also, just more broadly, what constitutes things like important or interesting work? Is this worth doing? Is this something worth publishing? And where is it worth publishing? Are all very much social norms, a little less clear cut. And then even beyond that, how do we divide up labor? Do we do reviewing, editing, and service? And if so, how much? Standards for promotion and tenure. These are all different norms. The ones we're going to talk about today are ones that might at first blush seem quite silly and uninteresting, which are the norms about author orders on papers. Now, the reason that it seems that part of the hope of this talk is that by the end, I will have convinced you that it's not silly, and it actually might have real epistemic consequences, which norms we adopt in different circumstances. So that's going to be the norm we focus on. And we're going to ask two related questions about that norm, right? So, or about those norms, I should say. The first question is the kind of anthropological or sociological question. Why did the norm evolve? And in the context of authorship norms, this is particularly interesting because different disciplines have different authorship norms. Some disciplines, it's alphabetical. Some disciplines, the author who did more is listed first. In some norms, the senior author is always listed last, regardless of how much work they did. Some disciplines have tried, although unsuccessfully, I think, to get off the ground that you just flip a coin to decide who's first. And then there are disciplines like philosophy that seem to be a kind of hodgepodge of different disciplines, depending on who's involved and the situation. So understanding why there's differences, if that's just random or arbitrary, or if there might be some underlying explanation for it, is a kind of anthropology or sociology of science question, which we're interested in. The second question is a more normative question, which is how do these norms affect scientific progress? That is one of these norms better or worse in any sense from the perspective of progressive science, of making science progressive, or is it really just an arbitrary norm that it doesn't much matter? And we're going to ultimately argue that it in fact does matter, and that how it matters is actually slightly different depending on the norm, that they have different epistemic consequences for, in particular, collaborative. Okay, so to jump into this a little bit more, the way we're going to approach this is the way lots of people approach studying norms is with the game theoretic model. Of course, anybody who knows me will be completely unsurprised by that. What we're going to do in the first part of the talk is consider a competition between two norms. All right, so we're not going to assume the full universe of potential norms, but rather we'll just assume that you have a scientific field where there are two norms in competition with one. One norm we're calling the contribution insensitive norm. Okay, so this is the norm that just says, I don't care who did what work, there's just a pre-specified way that the authors are listed. Alphabetical is a super common one, and that's going to be the kind of motivating example that I oftentimes appeal to, but also senior author last is another one of those. Doesn't matter whether the senior author did more or less, they get put at the end. And that's biology, medicine, use senior author last. Alphabetical is used in mathematics, economics sometimes, although it's complicated, and so those norms exist. The second one is a single norm, contribution, what we're calling a contribution sensitive norm, which is the idea that the author order reveals immediately who did more work. Most commonly that norm is first author did the most work, second author did the second most. If there's a third and a fourth and a fifth author, they did less, right? We could do it anyway. You could, I mean, in theory, we could have third author did the most work or something, but we'll just assume that it's first author. Okay, so we'll consider these two norms, and we'll just consider situations with two authors, just to make our life easier. Yeah.
So you're not, when you say, like, for example, senior author last, it's not in combination with any contribution sensitive.
Yeah, and
two authors.
yeah, exactly. So part of the reason we're limiting ourselves to just two authors is because we do want to consider a situation where there are just these two norms and where there's no hybridization of them. Because one thing that happens, like in biology, is senior author is last, but the first author is the one who did the most work if there are more than two authors, right? So if for instance, like there's a paper I published, Zollman, Bergstrom, Hudiger, right? And we did that because for weird reasons, because Bergstrom was the most senior, but we wanted to indicate that he didn't do the most work, and so we put him in the middle because that was sort of the least valuable, right? We were trying to screw with the norms of biology. I mean, I don't know what we were trying to do. we did what we did. No regrets. I was first off, so no regrets. You know, especially the alphabetical one. I mean, I joke around about this, has a particular sensitivity for me as somebody who in the alphabetical. Okay, so we're just going to consider a very simple setting. Two authors. I'm going to give them names: Adam and Babbage. Adams and Babbage. We'll assume that if they adopt the contribution insensitive norm, Adams is listed first and Babbage is listed second. That could be because of alphabetical, that could be because Babbage is the senior author, but whatever, that's just how we're going to do it. And then the other possibility is the contribution sensitive norm, where whoever did more work gets listed first. Sometimes that might be Adams, right? Adams might have done more work, or sometimes that might be Babbage. Okay, so we're going to try and answer these two questions about these norms, right? Both norms are present in different fields. Why? That's going to be our first question. And then the second one is, again, restricting ourselves to just considering the two different norms and just two author situations. Do they affect scientific progress in any way? And in particular, do they encourage or discourage collaboration? And the answer will be they discourage collaboration in some contexts, and I'll be able to say more about how they compare to one another. Okay, so first, norm evolution. To do this, we need to make the model a little bit more precise. So I'm going to give you a high-level model. It sounds worse than it is in a certain sense. So I'll give you the kind of order of operations. So the idea is Adams and Babbage come together, and they think, hey, maybe we should collaborate with them. We're going to assume that they do that thing that like all the scientists tell their graduate students to do, even though they don't do it themselves, which is discuss authorship norms before they start the collaboration rather than after, right? If you read all of these guidelines for graduate students, they always tell you to do this. So they each say, here's the norm I want to use, right? So one of them says alphabetical, one of them says, contribution sensitive or something like that. If the two norms are, so the two norms are an insensitive norm, which lists Adam first and Babbage second always, or a sensitive norm, which lists the person who did more work than the other. Okay, so those are their two options. Each of them just has a norm. Okay, if the norms are compatible, they collaborate. What do I mean by compatible? Well, if they're the same, first of all, they collaborate. So if they both say insensitive, then Adams gets listed first no matter what, they go ahead. If they both say sensitive, then they go ahead and then at the end figure out who did more work. We'll assume that that's obvious, that there's no ambiguity about that, and whoever did more work gets listed first. The other compatible example is actually this one, where Adams says whoever did more work should be listed first, and Babbage says, no, you should be listed first, right? That's technically speaking incompatible because they're proposing different norms, but it's one of these, no, you go first, no, you go first. So we'll assume that if that happens, they do both side if there's some uncertainty. So these are the three compatible norms. The only incompatible norm is if Adam shows up and says alphabetical, and Babbage shows up and says contribution. Because that's the case where Adam says, I want to go first no matter what. And Babbage says, no, what if I did more work? If that happens, they don't collaborate, right? So the collaboration fails, they don't bother. Otherwise, they go ahead and collaborate. Nature decides who did more, right? So we'll assume that there's just some external fact about the world that decides who did more work. This could be because one of them is smarter than the other, one of them has access to better technology or information. It could be because they have more resources or they have more spare time, who knows what it is. And it's just drawn from some distribution that's specified in advance, right? And so that distribution just says, here on the x-axis, how much what percentage of the work did Adams do? So 1 means Adams did literally all of it. 0 means Adams did literally none of it, and everything in between is we'll be showing a lot of these graphs. So these are useful to sort of think about. And then, of course, if Adams does 60%, then Babbage did 40%, because we're assuming only 2 collaborations. All right, once that happens, they publish. So they take the work that they've done. Hooray, they succeeded. They publish. They always publish. They find somewhere at least to publish it. And then they publish according to whatever norm they agreed on and whatever contributions were, if that was relevant. So if Babbage did more work and they agreed on the sensitive norm, then they do the bottom. Otherwise, they do the top. Once that happens, the scientific community sees the paper. They say, oh, look at this great paper that Adams and Babbage have written together. But now we have to sort of dole out credit, right? The paper is worth some amount of credit, right? That is, it has some importance to the scientific community. And so the scientific community has to decide how much do we want to reward socially Adams and how much do we want to reward Babbage. So we're going to assume that the scientific community is aware of a couple of things. First, the scientific community knows whatever this distribution is. That could be because they know Adams and Babbage personally and they say, oh yeah, Babbage is obviously the smarter one. Or it could be because they know features about people like Adams and Babbage. So they could say, well, in this field, normally the graduate student does most of the work, right? And so we're going to assume that probably in this case, the graduate student did, or vice versa, right? So whatever that is, they know the distribution, but they obviously don't know in this particular case who did more work. They only know the distribution as a whole. The other thing that the scientific community knows is they know in this community how often are the different norms followed, right? So they know how many people follow the alphabetical norm, how many people follow the contribution norm. So they don't know in this case that these are alphabetical or not alphabetical, but they know that in general, most people follow alphabetical, or most people, okay? So the relevant thing to think about, and this will be a fact that is quite relevant for the talk, and I think maybe in a certain sense, the most critical thing of everything. If the scientific community knew that they were following, say, the alphabetical norm, then the scientific community would have no idea who did more work, right? They would just look and say, okay, Adams and Babbage collaborated, but I don't know who did more work. So as a result, they'll just take a guess, which is based on some prior about how likely it is that Adams did more work and assign them more credit. So if we're thinking about the case of like a senior-junior collaboration, if this is a field where usually the graduate student does most of the work, they'll say, well, I think probably graduate student did most of the work, so I'm going to give most of the credit to the graduate student. Or if it's a field where Adams is the famous one and Babbage is not famous, they'll say, well, Adams is the famous one, probably did more of the work. So they'll just guess. If they knew for sure that they were following the contribution norm, well, now they would know for sure who did more work. So if Adams was listed first, they say Adams definitely did more work, but they don't know how much, right? They know that Adams did more than 50% of the work. So what they would do is they would say, let's suppose, sorry, it's a little hard to see because of the colors. I didn't realize it would get washed out, but if you can see it, there's a shaded area here that starts at 0.5 and goes to 1, right? So they know Adams did more work, but they don't know how much more work, so they'll assign what is called the conditional expectation of the distribution, which is how much work on average Adams does, given that he did more than half. And then similarly, if Babbage gets listed first, they do the same, but in reverse. All right, so that's the game, right? They play the game. And so first they decide one of the two norms to use. They then go through this process. They get rewarded based on what the scientific community thinks they probably did. And that you can sort of think of that as their payment, and then that keeps going. One small thing for those of you that are game theorists, for technical reasons, we'll assume a tiny bias towards the first author, regardless of what norm is enforced. If you're curious about why we're doing that, I can tell you in a question. It's a tedious technical reason that most. It can be literally as small as you like, so it actually sort of doesn't. Let me just skip that because that's even more tedious. Okay, so the substantive assumption here, and one that we're thinking about, it matters, not a ton, but we're thinking about how much we care about it. We are assuming that they discuss authorship order before embarking on collaboration. And if they disagree about it, they don't even bother collaborating. We could have arranged these differently. We could have had them collaborate first, then discuss author order, and only if there was a conflict, fail to publish. And that actually does make a slight difference. So what might have felt like an arbitrary decision is not entirely arbitrary, but we don't think it makes any philosophical difference. That is the qualitative conclusions. But I do want to be honest that it's a real story. Okay, so we got a game. It turns out it's what's called a coordination game. So there's 3 equilibria. The first is where they both, no surprise, right? The first is where they both adopt the insensitive norm. The second is where they both adopt the sensitive norm. And then there's a weird mixed equilibrium that doesn't really matter. So the idea here is that first, already this game underwrites the fact that there are norms in a scientific community. This predicts that given enough time, a community would settle on one norm or another. Doesn't quite explain why we have some communities that are in transition, although there can be particular explanations for why that's going on. Usually the ones that are offered is because the discipline is coming into contact with another discipline that has a different norm. So why is economics a little unstable right now? They used to be alphabetical absolutely always, but psychology is not alphabetical, and behavioral economics is bumping into psychology, where now they're having to negotiate what happens when a psychologist and an economist. So that's the story. So this is good. But it doesn't answer the question of why are some disciplines in one state and some disciplines in another state. And so for this, we'll turn to an evolutionary model. And in the evolutionary model, we'll just assume that we have a population of people, which some people are alphabetical people and some people are non-alphabetical people, and then they play the game and then they either imitate others or they're replaced by people who do better than them. So this is a kind of simple cultural evolutionary model where people who do better reproduce, in a certain sense, their norm, and people who do worse don't reproduce their norm. And we find that which norm is more likely to evolve depends on the shape of that underlying distribution. So let me just walk through a couple of examples with you. This one is, who knows, right? This is we have no idea. Adams and Babbage are unknown to us. We have no reason to think either one of them did any more or less than the other. It's sort of total ignorance. In that context, then each norm is equally likely. Neither norm is more likely than the other, right? So it just depends on where you start. This is a plot of how the evolution would proceed. So this is the Adams population strategy. This is Babbage's population strategy. And then this is where everybody is doing the contribution norm. And this is where everyone is doing the insensitive norm. And so we just end up in one of those 2 corners, and it's equally likely that we end up in either one. All right, that's not particularly interesting. This is the more interesting and somewhat counterintuitive result. So this middle graph is the graph where Adams is the one who usually does more work, right? So Adams is the famous one. Adams is the senior author one. Adams is the smarter one. I don't know what. But for whatever reason, everybody thinks it's much more likely that Adams does much more work. In that case, we are far more likely to evolve to the contribution norm than the insensitive. So when Adams is the better one, Adams says, both say in the long run, we should just do authorship order according to who did the more work. When Adams is the weaker one, which is this graph on the right-hand side, we're far more likely to end up with alphabetical. And that feels very counterintuitive, right? If Adams is the smarter one, shouldn't Adams want to always be listed first and so prefer the insensitive norm? And if Adams is the weaker one, shouldn't he sort of not get his way and they end up why do they end up, when Adams is the weak, this is the most surprising one, right? When Adams is the weaker of the 2, they most often list Adams first. That seems kind of weird. And the reason this has to do with a very subtle thing about how these 2 things play off against one another. So if we think over here, Adams does most of the work. So if they're in a situation where they list themselves alphabetically, if they're in a situation where they list themselves according to who did more work, Adams most of the time will still get listed first, and he'll get more credit that way, because people will know Adams not only got listed first, but he did so because he did more. So he'll get a much larger share of the credit in that situation. So most of the time it's the same outcome, but he gets more credit in that situation. So Adams actually prefers this outcome. And over here, Adams weirdly prefers this outcome because, Babbage, let's see, let me make sure I'm saying the right thing. So this is the outcome where Adams usually contributes the least, And alphabetical is actually good for Babbage because now Babbage gets more credit, especially when he does less of the work, right? So it's not revealed that they're way out over here in the tail. People are always giving him credit, even. Yeah.
So this is just for alphabetical ordering.
It could be for senior too. And actually, I think that this particular asymmetry might be what explains the difference between alphabetical and non-alphabetical. And let me just give an entirely made up just so story to kind of motivate it. So math uses the alphabetical norm here, and let's see, am I getting this right? Math uses the alphabetical norm, and oh no, I'm sorry, I'm going to get it back. Sorry, ignore my just so story. This is why it's a work in progress. So never mind, we'll skip that. But what this says is that in cases, if we were thinking about this in terms of senior junior, Babbage is the senior, Adams is the junior. So in disciplines where the junior author does most of the work, you're most likely to end up in a situation where the author order represents who did more. In a discipline where the senior author does most of the work, you're more likely to end up in a discipline that's insensitive to that. Okay, so this was my justification. It does make sense. I talked myself out of it, but I found myself back in it. Biology. Let's suppose that in biology, the most important thing is setting up the lab, getting all of the equipment, getting the funding. That's the lion's share of the contribution to the science. Then we would expect that in biology, the senior author would always be listed last. Right? And then let's say in math, anyone who's as old as I am can't possibly do math anymore. The best math is done by young people, which is the kind of thing that people say. In that, we should expect that the contribution is more. Senior authors are not listed last. So math actually is alphabetical, but we're only considering two. So this is we think a kind of interesting and somewhat counterintuitive finding that will at least relate one empirical fact about a discipline to what norm that we expect. That is, if we're considering how likely it is that say a senior author is going to be contributing the lion's share, that will tell us whether or not it's more likely that it has senior author or a contribution. Yeah.
I just want to clarify a couple of things.
Mm-hmm.
Like, firstly, are the distributions exactly symmetric for the second case?
They are, yeah.
Okay, and then are you equally likely to begin anywhere on the square?
Yeah, we could think of it that way. So when I say one is more likely than the other, what I technically mean by that is the number of points that eventually converge here and the number of points, or the size of points, the measure of points that converge here are the same size. And when I say you're more likely to converge here, I mean there are more points that converge here versus there. So yeah, so that's equivalent to saying, the initial state of science is a random point.
And then in the second case, you're almost certainly going to end up at the where the ordering depends on the contribution. In the third case, you're more likely to end up where it's insensitive.
That's right.
But I'm wondering, it seems like there's a larger portion of the third case that ends up going to the sensitive norm than there is of the second case going to the insensitive norm. And I'm wondering sort of if you have an intuitive thought as to why that might happen. It's it seems more likely, if that makes sense. In the third
I
case.
see what you're saying. That may just be a bad artifact of the way mathematical plots this.
Okay.
It's I should check. I don't know. I don't know for sure. That's a good thing for me to check. I would be shocked if that was the case. So yeah. So it was a good question, a very good question.
But it seems pretty
I'm guessing that probably that's more of an artifact of just, these are all numerical, so there's lots of little twiddly bits that might screw it up. I think, yeah, but that's a good question. I'll have to look into that because I honestly don't. I can't say for sure that it's not that. I would be surprised if it was, but it's not impossible. The game is not perfectly symmetric, so it's not the case that I can't tell you that it's mathematically impossible. Oh, good. Okay. So this is just to state in words the counterintuitive result. If Adams usually does more work, then author order represents effort. If Babbage usually does more work, then author order lists Babbage last, which sort of seems a little counterintuitive because I built in already even a small bias toward the first author. This has another way of saying what I just said is this has something to do with the relative speed of selection in the two different populations, which relates to some other issues in both social and biological evolution in game theory. But let me just say one more thing before I move on. Who cares, right? So it's a bunch of detailed analysis, and you might think, why does it matter? But in particular, I think that this, I mean, there are many ways to translate the formal result into things to say about science, but this one is the one that struck me as most surprising. There's this kind of sense, and I think even to this day, some sense that senior author last is a kind of magnanimous norm. When, you know, senior faculty is authoring with a graduate student or a postdoc or a junior faculty, they say, no, you go first, it's fine, it's fine. Right? I don't need the credit, you need the credit. So as a result, I'm doing something nice by putting your name first. But in fact, if that norm becomes widely adopted, it is no longer magnanimous, it actually has the opposite. Right? Which is, if it's the case that people tend to think that the senior author does more work, that's this picture here. In the case where the senior author is always last, author order doesn't reveal anything about who did more work. And so in this particular example, the senior author gets 60% of the credit and the junior author gets 40% of the credit. Whereas if author order actually reflected effort, then when the junior author gets listed first, they end up getting more like 65% of the credit, and the senior author only gets 35%. So what seems magnanimous, senior author says that the junior author should always be listed first, is magnanimous only if it's counter to the norm. But if it is the norm, then it's actually the opposite, has actually the opposite. Yeah.
So maybe I might be missing something, but I'm assuming all of these results are sort of for the infinite time horizon. So do you know?
Well, we're assuming yes and no. I mean, the evolution can go on for forever. So in that sense, but you could, I mean, these results would be perfectly valid for, you know, two authors come alive, author one paper together, and then die or something like that. So we're not assuming a repeated game where they have.
Yeah. Okay. And the field as well.
Yeah.
Again, some fields are more, they don't necessarily know their time horizon.
Yeah, and here, I mean, the evolutionary model in particular does assume that, you know, we have a long enough time for the system to evolve, and that might take a very long time for us. So, you know, it could be that some fields like philosophy are sort of somewhere here in the middle where norms are evolving and they're changing. There's uncertainty there. All right, so the second question that I said we would talk about, what are the consequences of these different ones? All right, so there's a bit of a technical issue here that I do have to mention briefly, which is how smart do we think Adams, Babbage, and the scientific community are? Does the scientific community know that some collaborations might potentially fail? Do Adams and Babbage know that? And I'm going to just talk about two extremes. One is where the scientific community is not particularly smart or sophisticated in terms of how they assign credit. And the second is where they're like ridiculously smart in how they assign credit. And the reality is probably somewhere in between, but I'll just do this. We can talk more about this details. Oh, did I miss a slide? Hang on just one quick second. I'm sorry about this. Seems like a slide got skipped. That's really strange. Okay, well, I can just say what was on the slide. Okay, so what we're going to do is we're going to assume a model now where there's already existing norm in force. So we're no longer assuming that the norms are changing over time, but rather the scientific norm of has been decided by the community. Okay, so there is a scientific norm that has definitely been decided on. Adams and Babbage now have to decide whether or not to co-author together or not. So we're going to assume that they get together. They already agree on the norm. They're following the community's norm. They agree on the norm and they co-author together. Let's assume that they do work together and that the work that they do together can be divided into three chunks. The part that Adams did all by himself, the part that Babbage did all by herself, and the part that's collaborative, that really is co-authored. And now, given how much of the work each of them did and the norm of the scientific community, they now have to decide, do we want to co-author together, or do I want to take the part that I did and publish it as a single author paper? Do I want to take my ball and go? So that's the decision that the two of them have to make. Right? And the decision will depend on the norm that the two of them are pursuing. right? So in one context, they might be pursuing, for instance, if they're pursuing the norm that is insensitive, so it's alphabetical, if Adams does almost all of the work, Adams might say, you know what? I don't want to do the alphabetical norm. I want to just publish this huge work that I did by myself and leave the collaborative work on the cutting room floor, so to speak. And alternatively, same thing. If Babbage did most of the work, Babbage might say, well, you know what? I don't want to do this. I'd rather publish it on my own. So the possibility that we now have to deal with in this context is the possibility that once they know how much they did, they may no longer want to co-author because they're going to lose too much credit in that context, right? So the idea here is that there's situations where they might lose. Now, when is it that they might lose? This is the thing that does actually depend on the norm in a kind of weird way. So if the norm is an alphabetical, that is, if the norm lists Adams first no matter what and Babbage first no matter what, then it depends on the times that people will abandon it are situations where they did the vast majority of the work, right? So Babbage will say, hey, if I did a vast majority of the work, it would be better for me to publish it by myself and get all the credit than to co-author with Adams and only get some of the credit. How much depends on who normally does more work. So if Adams normally does more work, then it will be the case that Babbage is much more willing to bail out on the collaboration, because in the alphabetical case, people say, oh, Adams normally does more work, so it must be the case that Adams did more work. Let me draw, sorry, I don't know what happened. One of my slides disappeared, but I can draw the picture. So if we have a case where Adams normally does more work, then Babbage will bail out in the context where Babbage did most of the work. It's also the case that Adams will bail out, but only in a smaller region at the other extreme, right? So if Adams says, no, I did so much more than people will think I did, I still want to bail out. So in the alphabetical case, whoever gets less credit is more likely to want to bail than whoever does more credit, but it can happen in both cases. In the case, so this is for the alphabetical. In the case for the non-alphabetical, it's a little bit weirder, actually. So again, I'll try to draw the same distribution. There are these regions where if one person does most of the work, they'll bail out. But there's also a region where if they contributed very, 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 very close to equally, the person who did almost but not quite 50% wants to bail out. Why is that? Well, if we know that the contribution norm is going on, say Adams is going to get listed first because Adams did most of the work, say that'll be like right here, then Babbage might say, you know what? Yeah, I know Adams did most of the work, but I did so much that I don't want to lose out on the credit that I would normally get, right? Because if we list Adams first, then people will think we're way over here, when in reality we're right here. So collaborations will also fail when they're very, very close to equal. So that's the first and somewhat interesting conclusion from this, is that which norm we adopt will have consequences for which kinds of collaborations succeed and fail. So the contribution insensitive norm, that is an alphabetical norm, is far more likely to discourage collaborations where one person did most of the work. Whereas the contribution norm is far more likely to discourage nearly equal contributions. So both discourage certain kinds of collaboration, but they discourage a different kind of collaboration. Which collaborations they discourage? So then we can ask a more broad question. Does one of them discourage more collaborations than the other? Like, what's the relative size of these two different things? That's the graph that in fact I do have. And so what we have, just to give you a sense of what we have here, these are just, these distributions are just for illustration. In fact, these plots are for a bunch of different distributions. The x-axis is the mean of the distribution. So this is just a picture of like how tight or wide is it. And the y-axis is how valuable, how big of a chunk of their collaboration is genuinely co-authored. Okay, so this side is Babbage did almost all the work. This side is Adams did almost all the work. The bottom is basically the collaboration is just duct taping two papers together, that there's no genuine collaboration. The top is like it's all collaborative. The color indicates how often collaboration fails. All right, so blue means collaboration succeeds, red means collaboration fails, and then white is somewhere in the middle. The first thing to note about this is no surprise. When there's no actually true joint work, nobody bothers to collaborate. Yeah, just publish your part on your own. Why not? You get more credit that way, right? Somebody will always want to do that. As there is more value to collaboration, though, there still are lots and lots and lots of failures, right? So that yellow color is in the 70% region. So in situations where there is still some genuine collaborative content, collaboration is still nonetheless likely to fail, 70% or 50% of the time, depending on which region. So that represents a real epistemic loss. That's a situation where there really was genuine value in their collaboration that does not get published because one or the other of them says, you know what, I'd rather publish on my own. That's true of both norms, right? So this insensitive norm and the sensitive norm both feature those regions. So it's not the case that we can say one norm is utopia and the other norm is purgatory. Both norms are going to result in failure. However, it is almost always the case, or actually in this context, always the case, that the insensitive norm is worse than the sensitive norm on average. Okay, so what does that mean? More collaborations fail in the alphabetical or the senior author last than fail in the context of the person who did more work gets listed. So if we want to say which norm is better or worse on average, we would want to say that the insensitive norm, alphabetical norm, is worse on average. Now, it's not like, because it's different types of collaborations that fail in the two contexts, it's not like we can say one is always worse or one is always better, but just on average, one is worse. I'll skip the slightly more sophisticated scientific community. Basically, everything I said is the same, except everything gets worse. So a smart scientific community that's paying attention to all of these weird game theory facts actually makes science a hell of a lot worse than if they aren't. So the cute part of this story is you'd rather a scientific community that's sort of strategically unsophisticated in thinking about how they assign credit rather than strategically sophisticated. Toby and I are still ourselves debating over whether we think both of these are of interest or not. And if you wanted more details about what the difference between them is, I can tell you. Okay, so let me just stop there and just sum up. So the basic questions, the two questions that I started with, the question is what causes the evolution of one norm versus the other? And the second is one norm better than the other? What are the epistemic consequences of the two norms? The first question is, it does seem like the relative contributions of the two authors on average affects which norm is going to evolve, but in at least what was to me a counterintuitive way. That is, when the person who would get listed first usually contributes more than the person who would normally be listed first contributes more, we're more likely to have a contribution sensitive norm. And when it's the person who's listed last normally contributes more, we end up with an insensitive, which sort of seems counterintuitive. The second question was, what's the consequence of this? All norms will lead to failed collaboration. So all norms make science worse, in a sense, than if nobody cared about credit, for instance. But when comparing the two different norms, there's a real sense in which we can say that the insensitive norm, like alphabetical or senior author last, actually is worse for science than one that pays attention to the relative contributions of the author. So something that seems somewhat, I don't know what's quite the right word, like silly or trivial or arguing about author order, and some scientists don't find it distasteful, it actually might be something that is, at least in some indirect way, valuable for science as a whole. Right, thank you very much.
It's like, oh, don't look at that clock, whatever you do. Like a few minutes, 7, 8 minutes, have some coffee, have some food. Self-destructive.
I guess I must have accidentally hit the yeah. But I still have them.